Think about the photos on your phone, the documents you save, or the videos you are watching right now. It feels like they will last forever because they are digital. But the truth is, our modern world is built on a digital foundation that is actively rotting away. Almost everything we create today is mathematically destined to disappear in just a few decades. But what if we could stop this clock? What if we could store human history inside a piece of glass that survives for thousands of years? Welcome to BitsDoc. Today, we're exploring Microsoft's Project Silica.
To understand why we desperately need this, we have to look at how actually the cloud and other storage technology works. The cloud sounds like a magical, weightless concept, but physically, it is just massive warehouses packed with millions of loud, power-hungry servers spinning hard disks and solid-state drives, and all of them face a fundamental enemy called data rot. The magnetic layers on hard drives naturally degrade over time, and the electrical components in SSDs simply wear out. A typical hard drive only lasts about 5 to 10 years. Even the high-tech magnetic tapes that major tech companies use for long-term archive backups must be replaced and recopied every single decade to avoid corruption. This means tech giants are trapped in a permanent, incredibly expensive loop of moving exabytes of data from old, dying drives onto brand new ones. It is an exhausting race against entropy that consumes massive amounts of energy. This is exactly why Microsoft Research stepped in with Project Silica. It first caught the world's attention when Microsoft partnered with Warner Brothers to store the entire 1978 Superman movie on a single piece of glass the size of a drink coaster. Over the years, this has evolved from a wild concept into a serious, peer-reviewed scientific milestone published in journals like Nature. The goal here isn't to make a slightly faster storage drive for your daily use. It is to build a medium that can safely hold humanity's assets for up to 10,000 years without requiring a single watt of power to keep the data alive.
But how do you actually write digital data into a solid piece of glass? First, we need to clarify what kind of glass we are talking about. This is not the fragile glass used in your home windows or the basic glass sitting in your kitchen. Microsoft started with incredibly pure, expensive fused silica, and they have recently expanded the technology to high-density borosilicate glass. This is an incredibly tough, heat-resistant material similar to industrial lab equipment. To write the data, they use a femtosecond laser. This laser fires intense pulses of infrared light that last only a fraction of a trillionth of a second. Instead of scratching or etching the outer surface, the laser focuses deep inside the solid material. The intense energy creates tiny, permanent structural changes called voxels, which are essentially 3D pixels. The engineering challenge here is immense. If the laser fires too slowly, or if the temperature rises unevenly, the glass will fracture and destroy adjacent layers. But by controlling the laser with absolute precision, scientists can stack hundreds of individual layers of data inside a piece of glass just 2 millimeters thick. But writing the data is only half the battle. Reading it back introduces an entirely new set of complications. Because the data is buried deep inside a three-dimensional matrix, a regular digital microscope cannot decipher it. Instead, a specialized optical system shines a beam of polarized light right through the glass plate. As the light hits those tiny angled voxels, its physical properties change. The light emerges on the other side as a complex, messy pattern of shadows and distortions. To a human eye, it looks like complete optical chaos. To solve this, Microsoft feeds these complex light patterns directly into custom machine learning neural networks. The artificial intelligence analyzes the visual distortion, calculates the exact properties of the voxel that caused it, and instantly decodes the noisy optical signals back into the flawless ones and zeros of the original digital file. So when can you go out and buy a glass hard drive for your gaming PC or smartphone? The short answer is that you can't. There is currently no public accessibility, no commercial partner, and no retail pricing for this technology. Microsoft is building Project Silica strictly for what is called cold storage at a massive cloud infrastructure scale. This is designed for archival data that must be preserved forever, but does not need to be accessed every single day, like national archives, historical data sets, medical records, and cultural film libraries. It is a system built to sit quietly on a shelf at room temperature for centuries, requiring zero cooling fans and zero electricity until a robotic arm retrieves it. When you look at this technology, it really makes you think about how fragile our current digital lifestyle truly is. We are an advanced civilization that generates zettabytes of data every single second, yet we are remarkably bad at keeping it safe for the long term. We obsess over real-time internet speeds, but we completely neglect long-term preservation.
Project Silica is a powerful reality check. It reminds us that if we want our history, our science, and our stories to survive long after our current silicon chips crumble to dust, we have to start building things that last. It is humanity's insurance policy against forgetting its own past. If you loved this deep dive into the science defining our future, make sure to subscribe to BitsDoc. And if you want to see how our data travels through the vacuum of space, click right here to watch our last video breaking down the physics behind Elon Musk's Starlink. I will see you in the next one.